Hi, fourth graders. Welcome back. We are going to do lesson 12.2 today. So the objective of this lesson is to be able to identify patterns that develop or grow as we investigate a growing relationship between successive squares. That just means the squares that you are going to keep adding on. So we're going to analyze the visual pattern, which is the picture itself, and number patterns, okay, and how they're related or connected with one another. So let's take a look at these pictures. So they're all numbered, which is very important. They go in order. So we start with picture 1. There's an orange square. Picture 2, we can see that they're adding 3 blue ones. Picture 3, they actually take picture 2 and then add on the orange squares. Right, so this pattern is going to continue. Now there's a table down here where we are recording the number of squares or tiles, they're calling them. So in picture 1, we can see that there's just 1 tile. In picture 2, if we count, there are 4 tiles. In picture 3, if we count them, we see that there are 9 tiles. Okay. Now, if we draw picture 4, we can go ahead and just continue on to picture 3 here. We would be drawing these tiles along the border, and then don't forget this last one. So as you can see in each picture, it makes a perfect square. So if we were going to count the number of tiles in picture 4, we can see that there are 4 rows and 4 columns, and that would give us 16. Okay. Now let's see if we can figure out a pattern here. So I'm going to go ahead and change pen colors. Now if we look at picture 1, the number of tiles was 1. That is 1 times 1. If we look at picture 2, there are 2 rows and 2 columns. And we know from our lessons on arrays, that's 2 times 2 or 4 tiles. Picture 3, there were 3 rows and 3 columns. 3 times 3 is 9. When we added the tiles and made picture 4, we have 4 rows and 4 columns, which is 16. So without even drawing a picture, we would know that for picture 5, we would have 5 rows and 5 columns, which gives us 25 tiles. Okay. So what is the rule here? The rule is you take the picture number. I'm just going to write P and the number sign. Okay, and you're going to square it. So that means you're going to take the picture number times itself, right? Times the picture number. Okay, or another way to write it is you square the picture number. Okay, and a square number is just taking the number and you multiply it by itself. So now it says, without drawing pictures, how many tiles would be needed for picture 12? So you would just do 12 times 12, which we know is 144 tiles. And you don't want to have to draw all those pictures. You want to be able to figure out the number pattern or the formula. How many tiles would be needed for picture 20? Now that we know the rule or the pattern or the number formula, then it would just be 20 times 20, which we know is 400. Okay, so let's analyze some patterns here. So if we read right here, it says the area of the shapes to the side are called square numbers. Okay, because they make squares, perfect squares. The length and the width are exactly the same. So right here it says, for example, you can make a square with 36 tiles. Okay, because we know 6 times 6 is 36, but not 11 tiles, because there's no number where you multiply it by itself to get 11. So 36 is a square number and 11 is not. So let's take a look over here. They give us a table. Let's see if we can figure out the rule. So the length of each side. So if the length is 8, 8 times 8, the area is 64. Right? If the length of each side is 6, 6 times 6 is 36. If the length is 10, and we're talking about perfect squares, 10 times 10 is 100. Okay? So now you would have to figure out 15 times 15 and 9 times 9. Now we know 9 times 9 is 81. If you weren't sure about 15 times 15, you can solve it using the standard algorithm, okay? Or you can use partial products. Okay, I'm just using some room here that we have. So you could do 10, 5, 10, 5, right? And let me go ahead and enlarge that if that's easier for you. So 10 times 10 is 100, right? 10 times 5, 50. 10 times 5, 50. And then 5 times 5, 25. So either of those strategies. Now, if the partial products is easier for you, you can add up those partial products inside. 100, 50 and 50 is another 100. That's 200 plus 25. Okay, so if that's a faster way, 225. So that's how you would fill out that table. So what is the rule here? Again, the rule is, let's just say the length of a side, we're going to call it capital L. It's just L times L. Okay. Or another way to write that is L squared with a little 2 up above like that. If the length of each side of a square is 7, what would be the area? 7 times 7, or 49. Okay. Which of the following are square numbers? Circle them. So 16, because I know that is 4 times 4. Okay. 36, yes, that is 6 times 6. 6, nope. 2 times 3 is not squaring a number. 1 times 6 is not squaring a number. So that is not a square number. 4, yes, because I know 2 times 2. Okay, so that's what we're working on for 12.2 today.